Welcome to Lesson 3.1, Properties of Parallel Lines. In this lesson, we're going to identify angles formed by two lines and a transversal. So you're going to have to learn what a transversal is. And we're going to prove and use properties of parallel lines. First, a transversal is simply a line that cuts across two other lines. So here we have lines L and line M, and transversal T. T is the line that cuts across L and M, so that is our transversal. Now when you have two lines cut by a transversal, such as we have lines L and M with transversal T, you have certain pairs of angles. Our first pair of angles are going to be alternate interior angles, such as angle 4 and angle 8. Those are alternate interior angles. They're on opposite sides of the transversal, and they're on the interior of lines L and M. Angle 4 and angle 8 are alternate interior angles. We are just going to write AIA, which stands for alternate interior angles, as explained on page 127. Now pause the video while you try to come up with another pair of alternate interior angles besides 4 and 8. Hopefully you said angles 3 and angle 7 are another pair of alternate interior angles. They are on opposite sides of the transversal and on the interior of lines L and M. The next kind of special angle pairs are called same side interior angles. When you look at this figure, hopefully you will agree that we have a pair of same side interior angles right here with angles 7 and angle 8. Angle 7 and angle 8 are same side interior angles, which we're just going to call SSI. Same side interior angles. Now pause the video while you try to give another pair of same side interior angles. Angles 7 and 8 are on the same side of the transversal T, and they're on the interior of lines L, line L, and line M. Try to figure out another pair. Please pause the video. Hopefully you came up with angles 3 and angle 4 being same side interior angles. They're on the same side of the transversal and they're on the interior of lines L and M. Our next type of special angle pairs are corresponding angles. Corresponding angles are angles that maintain similar positions in when you have two lines cut by a transversal, such as angle number 1 and angle number 4 are corresponding angles. You see in the upper group of 4 angles, 4 is the upper left angle, and down here with lines T and L intersection, angle 1 is in the upper left. Upper left, upper left. Angle 1 and angle 4 are corresponding angles. Please pause the video while you try to come up with another pair of corresponding angles. There are 3 other pairs of corresponding angles. Hopefully you will agree angle 2 and angle 8 are corresponding angles. Angle 3 and angle 7 are corresponding angles. And last we have angle 5, upper right, upper right. Angles 5 and angle 6 are corresponding angles. The first postulate we need to talk about in Chapter 3 is the corresponding angles postulate that says if a transversal intersects two parallel lines, then the corresponding angles are congruent. Remember, a postulate is something we accept to be true without proof. Now remember, you can never use the number of a postulate ever. And sometimes you can use its name, but I am not going to allow you to use corresponding angles postulate in this class. Whenever we're referring to this postulate, I want you to say, if parallel lines, then corresponding angles are congruent, like I have written here. And I will explain, the reason will become clear to you more later in Chapter 3 why we have to say what I have down below. Again, write this down in your notes, just the way I have written it. If parallel lines, then corresponding angles are congruent. Now the first theorem we have in Chapter 3 is called the alternate interior angles theorem, which says if you have a transversal intersecting two parallel lines, then the alternate interior angles are congruent. Hopefully in this figure you realize angles 1 and 3 are alternate interior angles. If your lines are parallel, then those two angles will be congruent, and we're going to look at a proof of that shortly. But first, I want to show you how to write, how we're going to write this theorem in our class. This is how we will write the alternate interior angles theorem in our class. If parallel lines, then alternate interior angles are congruent. Please put this in your notes and make sure whenever you're referring to this theorem, that's how you write it. Next, we have the same side interior angles theorem, which states, if a transversal intersects two parallel lines, you can see transversal T is intersecting lines A and B, and you can tell they are parallel because we have arrows on them other than at the ends. Then the same side interior angles are supplementary, which means angles 1 and angle 2, which are same side interior angles, are going to have to add up to 180. The way we are going to state this theorem and the way we're going to write it in class is in blue. If parallel lines, then same side interior angles are supplementary. Please put this in your notes and make sure you know what it means. Now we have to look at one of the most important things we are going to learn in this class, and that is how to do a two-column proof. We're going to look at several different ways to prove things, but the way we are going to use in this class, whenever I assign a homework assignment or in class, will always be a two-column proof. There are certain parts to a two-column proof that you must always have. First, you have to state the given. Then you have to state what you are trying to prove. Then you must draw a figure. Then you're going to have the two columns with the column headings, statements and reasons, and then you will write the given down as the first step. And then you will proceed, and your last statement will always end up with what you're trying to prove. Okay, let's look at our first proof. Here we are given lines A and B are parallel. You can see the arrows other than at the end, so you know they're parallel. We're trying to prove angles 1 and 3 are congruent. So we're trying to prove if parallel lines, then alternate interior angles are congruent. So we have the given, what we're trying to prove, we have the figure, we have the two columns with the column headings, and we have the given as the first step. Now, whenever we make a statement, we're going to have to justify it or give a reason that it's going to be a definition, postulate, or theorem. In this figure, we can state angle 1 is congruent to angle 4 because if you have parallel lines, then corresponding angles are congruent. Next, we can state angle 4 is congruent to angle 3 because of vertical angle theorems. We know from the vertical angle theorem, vertical angles are congruent. Our last step is then going to be angle 1 is congruent to angle 3, what we are trying to prove. Your last statement will always be what you are trying to prove. Why? When we put steps 2 and 3 together using the transitive property, we can get 1 congruent to 3. If 1's congruent to 4 and 4's congruent to 3, then 1 has to be congruent to 3, by the transitive property of congruence. Last thing I want to talk about in this lesson are the alternate interior angles theorem and the same side interior angles theorem. Hopefully you will look at the figure and agree that angles 5 and 6 are alternate interior angles. Therefore, they are congruent. If angles 5 and 6 are alternate interior angles, what do you think angles 1 and 3 would be called? Hopefully you would agree those are alternate exterior angles. They are on the exterior of lines A and B on the outside, and they're on alternate sides of transversal T. Hopefully you would also agree angles 2 and 8 are alternate interior angles. The way we are going to say this and write this in class will be if parallel lines, then alternate exterior angles are congruent. If angles 5 and 7 are same side interior angles, then hopefully you will agree angles 2 and 3 are same side exterior angles. The way we are going to say and write this theorem will be if parallel lines, then same side exterior angles are supplementary. We will look at examples 3, 4, and 5 in class. This concludes Lesson 3-1.